Welcome to the YouTube channel PCMB Tutorials. Today we are going to learn Class 9th Chemistry chapter Periodic Classification, and this is our part 3. In this part, we will start learning with the law of octaves by Newlands. Our topic is second law of octaves by Newlands. In 1866, Newlands, an English chemist, arranged the elements with respect to their atomic weights. In such an arrangement, he found that the properties of every eighth element was a kind of repetition of the first element, just like the eighth note of octave in music. Again, I'll repeat. In 1866, J. Newlands, an English chemist, arranged the elements with respect to their atomic weights. In such an arrangement, he found that the properties of every eighth element was a kind of repetition of the first element, just like the eighth note of the octave in music. Now, the arrangement of Newland's elements was in increasing order of their atomic weights. Like first, if he placed lithium, then beryllium, boron, carbon, nitrogen, oxygen, fluorine, then sodium directly, sodium, magnesium, aluminium, then silicon, phosphorus, sulfur, chlorine, like this. This is boron and carbon, nitrogen, oxygen, fluorine. Then he placed potassium, calcium, chromium, tin, manganese, iron, and then bromine. This was like the Newland's arrangement of elements with atomic masses. Now, in Newland's arrangement, it is observed that sodium is the eighth element. Sodium is the eighth element from potassium. Sodium is the eighth element from lithium, and potassium is the eighth element from sodium. Likewise, again in this magnesium also, magnesium is the eighth element from beryllium, and calcium is the eighth element from magnesium. This is similar to the repetition of eighth note on an octave. The conclusion was that when elements are arranged in the increasing order of their atomic weights, then every eighth element resembles the first, like the octaves in music. Octaves in music are like sa, re, ga, ma, pa, da, ni, sa. Hence, it is called the Newland's law of octaves, and the group are 8 elements. So arranged was called Newland's octave. With the discovery of rare gases, this law of octaves failed in arranging the elements periodically. Now, there were some achievements of Newland's classification of octaves. Achievements. First was atomic weights as the basis for classification. Now, atomic weights of an element was recognized as the basis of classification of the elements. Second, periodicity. The periodicity as fundamental property of elements was recognized for the first time. Now, there are the reasons for rejecting Newland's classification of octaves. Reasons for rejection. First was applicable only till calcium. It is applicable for the elements up to calcium. It failed with heavier element beyond calcium. Second is improper placement of hydrogen. Now, it did not provide any specific place for hydrogen. Third is odd grouping after calcium. So, when the table was extended beyond calcium, odd grouping was formed. Fourth one is non-recognition of traditional elements. Means it did not recognize the traditional elements like gold, silver, copper, etc. Now, this was all about the Newland's law of octaves. Now we will learn Laudermeyer's contribution. Who was Laudermeyer's contribution? Now we are going to learn that. Laudermeyer contribution. Laudermeyer's contribution. Laudermeyer related the atomic mass of an element with its physical properties like density, melting point, boiling point, etc. A graph was plotted between atomic volumes of the elements and their atomic masses. This curve was called the atomic volume curve, where elements with similar properties occupied similar positions on this curve. So the curve is like the curve was like this. This type of graph was formed. Again, I'll repeat the statement. Laudermeyer related the atomic mass of an element with its physical properties like density, melting point, boiling point, etc. A graph was plotted between atomic masses plotted between atomic volumes of elements and their atomic masses. This curve was called the atomic volume curve, where elements with similar properties occupied similar positions on this curve. Then there is a term atomic volume. It means that atomic volume of an element is the volume occupied by 1 mole of atoms of the element in a solid state. Like for example, the most electropositive alkali metals occupy the peaks of the curve, the peaks on the curve. The less electropositive alkaline earth metals occupy the descending positions on the curve. The most electronegative element, that is halogens, occupy the ascending positions on the curve. On the basis of this observation, Laudermeyer proposed that the physical properties of the elements are the periodic functions of their atomic weights. He arranged the known elements in a tabular form in the order of their increasing atomic weights. It may be pointed out that the general pattern of the curve remained the same. When atomic numbers were plotted in place of atomic weights as a result of the later developments. I hope you've understood till this. This was the part 3 in which we've learned about Newland's and Laudermeyer's discoveries. In part 4, first of all, we'll learn two short topics. First is Ton's return to haunt the scoffers. Second topic is Mendeleev, the Siberian magician, the father of the periodic table. And then we will learn the half story of periodic classification by Mendeleev, the fourth discovery, and then in another part, in part 5, we'll continue the same discovery. I hope you've understood this third part. For any queries and doubt, please join the Telegram link given in the description of this video. Like, this is the foundation of class 9th. We have covered the foundation of class 8th and 7th too. The links are given in the description. Please go and check through it. I hope you've understood till this. Let's meet in part 4. Thank you for watching. Sorry.